Hi, I'm Eliot Lash. I just recently moved to Sacramento, and I'm excited to be here. So today I'm going to do a 10-minute talk in 5 minutes, so bear with me. It's going to be fast. Let's talk about pixels. So yeah, shaders are pretty. I love shaders, and I'm going to tell you a little bit about why I like them and why they're so cool and what they are. First off, GPU. So the CPU, it's the central processing unit of any computer. It's general purpose. One core can only run one instruction at a time. Most programs, like your JS code or whatever, will run on the CPU. GPU is the graphics processing unit. It's specialized. It does the same thing to multiple data in parallel. It can run tens to thousands of data points per instruction. Why does it matter? Anything a GPU, a CPU can also do given enough time. Like a Pixar movie is pre-rendered. They can do whatever they want, take as much time as they want for each frame. GPUs are faster by an order of magnitude, which enables some graphic effects or other calculations to happen in real time. Which is what makes VR possible. You wouldn't be able to interactively move around a 3D scene with this level of fidelity if it weren't for GPUs and shaders. They can do lots of things, such as rendering 3D models, atmospheric effects, image post-processing, procedural textures, image and video generators. OK, so what's a pixel? Just quick review here. It's the smallest unit, visual unit a computer can display. It can only be one color. Quick overview of the graphics pipeline. So you start with vertices, which is your 3D geometry. Go into your vertex shader. It rasterizes. You run your fragment shader. It blends all of those shaders together, and then it renders to the screen. The vertex shader and the fragment shader are programmable. Today, I'm just going to talk about fragment shaders. So what's a fragment shader? It's a small program that tells each pixel what color it should be. So it takes uniform inputs that are the same for every pixel on the screen, like time, colors, other configuration settings, and textures, like a 2D image or a video. And it outputs fragments, which are basically pixel candidates. OK, time for a super quick demo. I'm using something called the ISF editor with the GLSL shading language. So just a demo really quickly here. ISF just lets you define a JSON file. Oh my gosh, I need to, sorry, unmirror my displays here. OK, great. So there's a JSON file up in the top of this shader, which just defines what our uniform inputs are. And then I've got just a function I got off the internet to convert hue saturation value to RGB. And then what this shader is going to do is it's just going to get the distance from a center point, which is a uniform variable, so the center can move. We're going to multiply it by distance scale. And then we're going to calculate the hue of each pixel by taking the distance. And we can look at the rest of the stuff later. But it basically yields something like this. So as we drag our cursor around here, that center point is moving around, and the shader is re-rendering every pixel. There's a couple other things that I added here. So there's this color cycle, which is just an offset to that color. So if we, oh my gosh, it's just small resolution. All right, so if we move this color cycle, it just changes the offset of these colors here. We can put a modulus on. So if that basically just divides it and gets the remainder, and then that sort of clamps the colors to a smaller range. And this distance scale is just a coefficient. And then I have this thing called auto cycle, which if it's enabled will just also add the time as an offset to the color. And what that basically does is it gives us an animation. So this is a simple video generator. OK, 1 minute. I'm going to go over filters really quick. So in this case, the filter is going to take a texture as an input, and then we're just going to read, for each pixel, we're going to read the color from the texture. We're going to get the length of that color, which is basically like it's the sum of all of its RGB channels, so basically its brightness. And if that pixel is lower than a certain threshold, we're going to change that pixel to have a magenta tint. So we can see here, if we, let's do some live video. Yes, hi. So as we turn this threshold up, you can see that it's finding those dark pixels and it's doing stuff to them. So that's a simple filter. Thanks.